and we're going to play with my Firefox or my IO lab. So you're going to do a couple of different experiments with your IO lab. One, we're going to be doing our force measurement item, and we're going to look at the force, and one of the things that we're going to have to do is we're going to have to determine the mass of our object here. So that's one of the things that we're about to have to do. The other thing is we're going to do the force due to friction. So one of the experiments that, or one of the things that you deal with is looking at what's the force that's going to equal my coefficient of friction times my normal force. So when we're doing our Firefox, if I'm on the flat side here and I'm going to pull on my force sensor, as I pull and apply force, guess what's going to happen? As I pull and apply force, it's not going to move, it's not going to move, and then all of a sudden it's going to move. All right. Well, when it moves, that's when my force due to friction is going to apply, so we can actually determine our coefficient of friction. There's another way we can do it. We can apply a force. I can do a force on my force sensor. I can apply a force and give it a push, and we can actually measure how far it moves. Okay, so we know what the force is that we applied, and we can measure how far it moves, so we can determine the acceleration of our device. So when you're doing your friction lab and it's asking you to apply a push, that's basically what you're trying to do. You're just applying that push. If I'm doing a pulling lab for my force due to friction, and you might want to compare. So I have a little rougher surface here. This is not the same surface, and I want to pull on my force detector to get it to move. We can see that versus pulling it on a smooth surface like this. I'm going to see a different coefficient of friction. So there's several things that you can do with that coefficient of friction. The other piece that we're going to deal with is our elevator lab. If you happen to get into an elevator, okay, we can go back to my, go back to my Firefox here. And in my Firefox, I actually have an elevator, and you click on that and you'll start to run it. And so I'm gonna act like an elevator here. I'm gonna start recording my data, and we're gonna go up in the elevator, and then we're gonna come down in the elevator. We're gonna go up in the elevator, and we're gonna come down in the elevator. And when you do that, you're going to record some data where you see the up and downs. Now, this data here doesn't do very much, but because I've got a lower range from my elevator. Now, if you're in a building that has lots of elevators in there, or you're in a high rise, you're going to see a lot clearer data. But we're going to do the same thing with our IO lab. You're going to act like the elevator, because we're about to determine the mass of our IO lab. You're going to act as the elevator, and you're going to be the string. So you're going to go up, and you're going to go down. You're going to go up, and you're going to go down. And you're going to be the elevator for your IO lab. So that's one of the things that you're going to end up doing for that laboratory. So what I'm about to do is I'm going to switch my camera here. Stop my share. I'm going to move you all out of the way, and I'm going to do my Firefox, or my sensor. Okay, so now you see the IO lab that's up and running on the data. I have my IO lab right here. First thing that we got to do is make sure it's turned on. And we're going to calibrate our IO, our device. So when you go to your calibrate, you're going to calibrate the acceleration, magnetometer, and gyroscope. So we're going to calibrate it. So the first thing you do is you're going to find the little mark that tells you your X, Y, and Z. And we're going to go ahead and do this. And you want to have those up. So I'm going to set my IO device up on my table, and I'm going to do that. And I'm going to say next. Then it tells you to turn it upside down, do the exact same thing. And I say next. Then it has you do it upright. There we go. Oops, I've got to go the other way. Hang on. I got to take my force sensor off. All right, there we go. We got that one up. And we say next. Turn it upside down. Do it again. Say next. Then we're going to do wheels up. And wheels down. And now we've done our calibration and we saved it. Now I'm going to put my little force ring back in. And what we're going to do is we are going to do our accelerometer here. We're going to turn that on, and we're going to turn on our force. And I'm only going to worry about the Y direction. I'm not worried about my X direction. I'm worried about the Y direction. And I'm going to set my device on the table, make sure it's flashing that it's on, and I'm going to start recording. So there it is. I'm recording. I'm not touching my force sensor at all, but you can actually see that I'm getting an acceleration due to gravity. I can come over here and I can measure it. And I've got a value of 9 point, hard to see on my table, but I got like 9.77. Okay, I've got that. So now we've got, that's what my acceleration due to gravity is. I can do an average here. We can actually get an average. So there I can go in and I can get my average value of my acceleration. Trying to read my screen from over there. That's over time. There's my average. My average is 9.81 for that. So we're going to write that down. I'm going to write my 9.81. And it says it's negative because I'm facing upside down. So I'm going to go ahead and clear that. I'm going to reset everything. Now this time what I'm going to do is I'm going to hold it by the force sensor and I'm going to record the data. And I'm going to stop. I don't have to worry about my X and my Y really. I've got a little bit more noise in the data, but I'm going to come over here and I'm going to look at my average force. My average force is 2.477. 2.477. Both of those are negative. So I'm going to come back here. I'm going to share my other screen. So that was my average acceleration. Pretty darn good. because we calibrated it, got it pretty darn well. That was my force. So this is my force. My force was in newtons. This is in meters per second squared. So if force is equal to mass times acceleration, the mass of my device is going to be the force divided by the acceleration. Okay, it's going to be the force divided by the acceleration. So now I'm going to have my negative 2.477 divided by my negative 9.81. This is in kilograms, meters per second squared divided by meters per second squared. I'm going to end up in kilograms. And it says my device is 0.252 kilograms, or approximately 252 grams. And so I've now measured my device. I can now play with that a little bit and do other things with it. Like I can put something that's heavier on there and see how the force is going to change, depending on what I do. And you're going to be looking at force is equal to mass times acceleration. So it's not going to be that difficult of a lab to play with. When you do your elevator, if I'm going to accelerate up, since I know the mass of my device and I can read the force, I can actually see the change in acceleration going up, and I can see the change in acceleration coming down. And that's basically what we're looking at in those laboratories. So that should get you some things about how to do those various labs. So hopefully that will help.